Okay, let's talk about nets and Platonic solids. So this cube can actually be unfolded, and each of these different sides laid out side by side, and this is what a net of a shape of any solid looks like, in this case Platonic solids. So this is how we would lay out a cube as a net. We'll look more at that down below. The net of a pyramid, this is a square pyramid, so our base is a square, and then we would just unfold this pyramid so that we have each of the sides, which are triangles, that would fold up together to make a point. The net of a cylinder has a circle on the bottom, that's our base, a circle on the top, that's the top, and then this bit actually wraps around to form the side, or sides. Now a polyhedron, polyhedra is the plural. Poly means many, so many faces. Okay, different than a polygon. It's a solid, and it has to have flat faces. A polyhedra can be named after the number of faces. So a tetra has 4 hedra faces. A hexahedron has 6 faces. Now there's some real special polyhedra that we call the 5, and there are only 5 Platonic solids. They are regular polyhedra, each with identical regular faces. Remember, regular means all sides and angles, but we'll go with sides for the moment, equal. So let's have a look at that. And the same number of faces meet at each vertex. So this is our regular tetrahedron, 4 faces, and those faces are equilateral triangles. So this is one equilateral triangle on the base, and then you can see behind that are each of these sides. They are regular, all sides equal, and if you look, we've got 3 triangles meeting at each of these corners, and the same number of faces meet at each vertex. So that's satisfied. That's one of our Platonic solids. This regular hexahedron, 6 faces, is also known as a cube to, people playing at home. It's got 6 square faces, and of course we know that a square is regular because all the sides are equal. And at each corner, at each vertex, we've got a dog barking in the background. We've got 3 of those square faces coming together, and that will be true of every single one of these places, every one of these vertices, every one of these corners. A regular octahedron, 8 faces, and they're all triangles. So in this case, it looks like a square pyramid, but remember there's nothing in between here. We've got a triangle and a triangle, a triangle and a triangle, and the same 4 behind them that we can sort of see in the background. There's nothing here, and this is not a square base. It doesn't exist. It's empty space. So our triangles, 1, 2, 3, 4 triangles meet at each of these vertices, and that will be true all around, which is why it is one of our Platonic solids. And the last one we'll talk about is the dodeca, 12 hedron faces. It's got 12 faces, and each of these are pentagonal. They've got 5. So this is really interesting. It's got 12 faces. Each of them are regular. Look at that same size pentagon. And each of these pentagons, 1, 2, 3, 1, 2, 3 pentagons meet at each point. So that's how we can call it a Platonic solid. Now we're going to draw a net for these puppies. A regular prism. Okay, there's a lot of ways that you can do this, but this is how I'm going to do it. I'm going to start with our base. And the base is going to be, when I lay it flat, it's going to look like a rectangle. And then these sides, if I start to unravel it, like if you had a cardboard box and you would cut it down one side, you get 2 sides, in between of which is the top. You've got the base on the bottom, a side, the top, which I'll color in here, and another side. So we're almost done, but we don't want to forget that we've got these end bits here that need to be accounted for, and I can put them alongside literally any of these. The base, the side, the top, the other side, doesn't matter. So I could do this, or I could do this, because if I folded it up, it would be better with a ruler. Or I could do, you know what, let's go crazy, and I can do this. There's so many possibilities. As long as they are connected to each other, because they will form a solid, If you can fold them up, then you have created a net for, in this case, a rectangular prism named after the base. Okay, a regular tetrahedron, tetra for hedron faces, and regular makes it one of our Platonic solids. Every face is going to be an equilateral triangle. So if I'm going to draw a net for this, I'm going to choose a base. Let's make the base the one that looks most flory, but they're all the same. So I'm going to draw my best version of an equilateral triangle. And even though they're not quite equal, I'm going to fake it by putting my little lines in. And then, if that's my base, I'm going to put my sides in. And I've got sides here and here. And with a ruler, gosh, that'd be even better. Then you can see how my base is there, and my sides have folded down, and that gives me the net of a regular tetrahedron.